Hey everybody, this is Drew from Filtra.io, and I realize that for most of you, this is probably your first time hearing my voice or maybe even seeing my face. And that means something very exciting is happening. So, this is the first episode of the Filtra.io podcast. For a long time, so many of you have asked us to take our text interview series and turn it into a full podcast with audio and video. And I'm happy to say we've finally done it. So I'm super excited. This podcast is going to be on YouTube, Spotify, and Apple Podcasts at least to start. It'll be on our website as well. And it would mean so much to me if you would go and follow us there or subscribe there. Just do whatever you need to do to make sure that you get all of our uploads. Now, with this being the first episode of the podcast, it was really important to me to make sure that we started off with a bang, and I think we have done that. So, today's episode is my conversation with Tom Praderio of Parallel. And if you don't know Parallel, they are basically making a next generation railroad or rail system that can use the existing railroad infrastructure that we have today. When I was studying for this interview, like I do with all the interviews, I realized pretty quick that I think what Parallel is building is misunderstood in a lot of ways. So a lot of this interview I spent just talking with Tom about their product and kind of understanding deeper some of the decisions they've made. And as we talked, I was pretty impressed. I think they've made some interesting trade-offs that have kind of clicked together into a solution that can actually potentially bring some new use cases to existing rail infrastructure. So I'm really excited about what they're doing. We also talked about kind of the embedded space that Tom works in and the outlook for Rust in that space. And as you might expect, Tom's very excited about that, and I'm very excited about that. I think it's just such a huge growth opportunity for Rust. And of course, Parallel is a huge Rust using company. Tom talks about how Rust plays a huge role in their stack in this interview. So I think you'll really enjoy this interview. And the last thing I want to say is that Rust jobs at Parallel are on Filtra.io. And that those are there along with Rust jobs at many, many other very interesting companies. And so if you're even thinking a little bit about kind of searching for that dream Rust job, I'd really encourage you after you listen to this to go over to Filtra.io and check out the jobs that we have on our job board there. And with that, I'm going to let you enjoy this interview. So, Parallel is probably a newer name for a lot of people who aren't combing the internet for Rust companies like I do. So could you start with just kind of the elevator pitch to orient people to what you guys are doing?
Absolutely. So, Parallel, what we're trying to do is we are bringing the efficiencies of rail transport combined with the point-to-point service quality of truck transport. And then behind all that, you get all of the environmental benefits just for free, along with the battery electric rail vehicles. So we're really trying to make shipping for customers easier, faster, cleaner, safer, using the rail infrastructure that already exists in the United States and worldwide as well.
So one of the things I like to ask about is kind of the founding of the company and the founding team, because I think that sort of like founder market fit thing can be really important. So tell me a little bit about how the company was founded, who was involved in that, and why this is the right team to work on this problem.
Yeah, absolutely. So a lot of the core team, including the founders of the company, had all worked together, myself included, at SpaceX before starting Parallel. And during SpaceX, wild place to work, really teaches you a lot of lessons about building reliable hardware, about finding ways to to build software and hardware that is going to work. It's going to work the way you think it is. A lot of it's a testing methodology. Testing like you fly is a big way that SpaceX manages to be so successful. So when we, for various reasons, decided to move on and tackle the next challenge, the team here was looking for, okay, how do we take that approach of building really reliable, well-tested hardware and software into an application that was going to help humanity and the planet a little bit more directly. And so a lot of things were considered. My founders originally, finally settled on, well, the rail industry. This is the thing. There's so much capacity in the rail industry in terms of the occupancy on the track. You can expand the rail corridors a lot more easily than expanding roads for trucking. And this is also during the coronavirus pandemic, when a lot of logistical stack-ups were happening, ports were congested, there weren't enough truck drivers. So the solution kind of just came together all by itself. Is, okay, what if we applied this rigorous hardware and software development to enabling more efficiencies in the rail sector? And so the founding team, we're trying to bring all the good elements of that SpaceX culture: rapid hardware iteration, strong emphasis on safety and testing and reliability, radical ownership of components in the team, making sure that the team is empowered to make decisions, and just an appetite for making the world a better place.
That's awesome. We talked before, and you mentioned the SpaceX thing, but I didn't think too deeply about it. But especially that testing culture, obviously, is kind of famous. Does that? This is a bit of a divergence from where I
Sure.
was gonna go, but do you? What does that look like for you? Are you throwing your vehicles kind of into the fire pretty
Yeah.
frequently?
So one of the ways that we took inspiration is, and this is very common in the aerospace industry in general, but in the aerospace industry, when you're building either a plane or a rocket, your opportunities of testing the whole integrated system are pretty limited. Like, you have to fly it in order to get it into real conditions, right? And that's really high risk scenario. If you don't get everything right, if you're not very confident the system's going to work, you can have a really expensive failure, right? So this is like, that type of conditions in your environments, by necessity, dictates that you have to have a really strong testing environment and testing culture. And so at SpaceX and in a lot of other aerospace environments, there's this concept of testing like you fly, building entire representative sets of hardware and software, having very complete test environments that capture all of the environmental conditions of where you're trying to operate. And so at SpaceX, we had hardware in the loop tables and test setups that would allow us to conduct entire missions with the real hardware that was on the rocket and the capsule, and we could run it through thousands and thousands of different configurations, simulating real inputs. The hardware thinks it's flying, and we're just simulating it all happens correctly. We've taken that approach straight out of the aerospace industry and applied it to the rail industry. So our rail vehicles, our software, all the way from our firmware and vehicle control software, all the way up to cloud software and user terminals, are all simulated in very high fidelity simulation environments along with our hardware, in making sure that we can test every single scenario, test for performance, test for safety, make sure that the system fails safe in the way that we expect it to, make sure it's following the rules of the road. And that's kind of how we're able to rapidly iterate on the hardware while still making sure that and the software, while making sure that we're hitting all those requirements.
That makes sense. So the other thing that I wanted to follow up on what you just had previously said was the trucking piece. You alluded to that. Um, and so when you talk about trains, most people think about in the US it's a lot of freight, and then I guess in Europe like passenger rail. Um, but you guys are looking at trucking, which I guess is a form of freight, but these sort of smaller loads and maybe shorter distances. Um, so why is that the target rather than anything else that you could do on rails?
So, yeah, great question. So this might be one of the most kind of misunderstood aspects of Parallel. We are train people. We love trains. We think trains are extreme. Traditional railroading is an extremely efficient way of moving goods. our technology is not intended to compete with or replace traditional trains. Like there's just no, if you have thousands and thousands of boxes of intermodal containers, or you have a lot of bulk, ore or coal or whatever to move, there's no better way to move it than with one big power unit at the front. What we're trying to do here is we're trying to bring the unit economics of that really efficient system down to smaller shipments and lower distances. So if you think about it, the way that modern railroading works right now, there's a high efficiency in getting a single control unit, a single locomotive, and then stacking as many cargo units behind it, right? The longer your trains are, the better your efficiencies of operation are. And that's really important for the railroads to be able to achieve the really high efficiencies that they do. The problem is, you can imagine, there comes with a lot of costs for smaller shippers. If you're a shipper that wants to move, say, 5 containers, and you only want to go a small amount of distance, if you're going to stack those 5 containers in the middle of a 2-mile long freight train, it means to drop those containers off, you got to delay every single other train, every other car on that train. There's a lot of complicated maneuvers to disconnect your cars from the middle of the train. It could take hours to do this on like a standard industrial siding, and a lot of times these complications mean the railroads just aren't interested in delivering smaller volumes of shipments and smaller distances, and so they let the trucking market just kind of eat that up. And then because trucks really are point to point, whereas longer trains need to be broken up and sorted at various yards throughout the country, it means that the quality of service you can get out of a truck is usually a lot faster and a lot more reliable than a train. You'll get your cars cheaper with the train, but it might take anywhere between 72 to hours to a week to get the delivery, and you don't know when it's going to show up. So that's not super useful for a lot of like just-in-time delivery use cases. So what we're trying to do is we're trying to blend those two of them. We want to bring trucking volume back to rail. If parallel is successful, this should end up making more rail traffic than less rail traffic. Like more traditional trains are running. And we think that we can be a solution not just for first mile, last mile deliveries from big intermodal yards, but also providing that point to point service just like a truck would. And we can get all the benefits of rail while still being able to provide the high quality of trucking service.
So, does all the rail that you would need to do that effectively exist? Getting into like doing these short routes between cities
Yeah,
locally?
really great question. There is a lot of rail infrastructure in the United States, and even the rail infrastructure that currently exists is a small portion of what used to exist in like the heyday of the rail industry back in the 1920s, 1930s, basically up until World War II when the interstate highway system started being built. There are a lot of different ways that you can solve this problem. There are many industrial facilities, especially large ones, that still have rail linked to them directly and get rail shipments today. And so that's like a really easy first market for us to be able to do point-to-point shipments. Then beyond that, there are a lot of industry development clusters around either tech zones or development areas where a developer would be building a large amount of heavy industry that's co-located, maybe sometimes near a highway or something. A lot of times these things are located next to rail. And it's just whether or not the volume exists for the railroad and for the developer to justify building a small spur line. And so we think that if we can justify the cost of doing that, we can serve like an entire industrial hub with just really short drays to and from a micro terminal located very closely. And so then you get all the benefits of rail without having to get long distance truckers. You're talking about moving a last mile that's sometimes less than even a mile, right? Just back and forth from a terminal, kind of like you would in a port. And then the kind of long-term use case is if you make it very profitable and you make it very efficient, then now it becomes profitable for the railroads to build brand new rail, whether it's over existing corridors that used to have rail or branching out into new areas, new ports like greenfield ports. So it really all just comes down to the unit economics. If you can make it effective and you can make money doing it, and that's ultimately what our pitch is. We're trying to make this a profitable businesses for the railroads and the shippers, and then oops, we happen to electrify the whole system, right? Like that's not that we're not leading with the green part. It is very important to us as a company, and we want to be leaning into that. But if we can make money doing this, if we can show that it's profitable, the rail will follow, and there's a tradition of doing that.
Um, so in terms of the kind of existing infrastructure that we've been talking about, and like, because it seems like the goal here is get more out of the existing rail in a way. So there's a ton of existing infrastructure. I feel like engineering wise, that's got to be an interesting challenge to figure out how to integrate with everything that exists already.
Yeah.
What are kind of some of the specific problems you've seen there and how you've tackled them?
So, you know, this is a big challenge. Also, we talked about profitability just before here, or efficiency, right? You have to make it worth the railroad's while and worth the customers. We live in a market economy. No one's giving away stuff for free. Capital improvements on rail lines are very expensive, right? It's a lot of horizontal infrastructure. You have to really be show that it's going to make the money back. The investment's going to be profitable. So one of our core tenets here is we want to make it so that the capex involved in deploying our technologies is absolutely low as possible, which means that we need to integrate with the existing infrastructure as it stands right now. Like we don't require a special type of right of way or weird tracks or maglevs or anything like that. We don't even need overhead catenary to be installed, which obviously would be a really awesome thing for the U.S. freight rail network, but very expensive to do. The ROI isn't there for most of the routes for them. And when it comes to software and integration, that's the big part too. Is we want to make sure that our system is totally compatible with current train control and dispatching systems, like more modern systems like PTC, but also it can work down to the absolute lowest level of train control on things like yard limits and other than main operation, work zones, all these kind of like special conditions that happen out in the real world. We want our system to be fully compatible with the railroad operating rules as they stand and not require any sort of special infrastructure. And that's kind of where the fun comes in. I mean, I thought I knew a lot about train control before I started this company, and I've learned even more. And there's so much more to learn too. It's a very exciting software challenge to be able to be compatible with all the ways that railroads do things right now.
Yeah, I bet. Um, so you mentioned earlier you were talking about one of the disadvantages with current freight trains is you're trying to stack as many cars as you can, and then you have this, you're trying to disconnect certain cars at certain points, and it introduces some inefficiencies. And I think that's where the platooning aspect of your solution comes in. Is that right?
Mm-hmm. Mm-hmm.
Can you speak
Yeah.
more to that? Because I, like, not being a railroad person, I don't totally understand all the benefits of that or how it would work.
Yeah, I mean, so for a lot of reasons, it's very beneficial for trains to travel in long sections of cars, right? Like it isn't, you don't necessarily want a rail system that's operating like a highway system where there's just individual cars going. For one, it's kind of a safety issue. Like trains are really heavy and take a long time to stop. You really want them to be traveling together in long batches. And then also when it comes to crossing infrastructure, like grade crossings or other tracks, you don't want like the gates to be coming down every 2 seconds because another train has gone by. So there are real network efficiencies to, even though our vehicles are all individually powered and are capable of traveling by themselves, when we're out on the main, we want to be traveling like a train does, right? This is part of that kind of integrating the way that trains currently work. The big difference between our technology and the way that traditional rail equipment works is that we don't physically couple together our cars. Because every single one of our cars is a fully self-contained and capable electric vehicle, we can have them push up against each other and maintain the train line through bumper compression. All of our vehicles have a bumper that senses force and displacements. So the lead vehicle in the train sets the pace, and every single other car behind it just maintains that constant pressure on the bumper. And if it detects that the car in front of it starts speeding up, it will speed up to catch it. And if there's a braking event and that bumper compresses, it'll come back. The actual algorithm is much more complicated than that, and takes into account a lot of safety and train line maintenance issues to make sure that we can operate the way that a normal train does. But the idea here is that if you can maintain your train line with compression only, then when you want to go break it up, there's almost no cost to doing so. So, for instance, that case where you want to drop off some cars, this operationally, depending on the type of equipment you have and depending on the conditions on the rail, this can be a very complicated operation for a traditional locomotive to do. For us, it's as simple as plugging into the system, and the train will come to a stop or even drop them off on the fly if necessary. You can just separate wherever it wants to, as long as the rules of the road permit it at that time. And then the vehicles themselves can then back into a siding and be ready for loading and unloading all by themselves. There's no secondary moves required by the engine crew. So the platooning is very core to this concept. It allows us to operate like trains do, but it also allows us to do things that trains could never do, which is this rapid drop-off and deployments, and then forming trains together, forming cars together to make trains on the fly. A lot of this, requires a lot of integration with the way that the dispatching software runs today, and making sure we're compliant with all the rules and operations on the road. But we think that this platooning concept is going to be able to unlock the best of both worlds, if that makes sense.
Yeah, that seems, obviously I really know nothing about the industry, but that seems big to me just from what everything I've learned through our conversation and my
Yeah,
research. That's
and
really
we do it. We have a test track, and there's some videos online of this. We have a fleet of vehicles right now we use for demonstration purposes and pilots to show to get into customer environments and go try delivering freight and prove the unit economics works. And we can do platooning with those vehicles at our test track, and we can show the coming together and coming apart, kind of show off to customers, investors, and regulatory agencies what exactly this technology allows to happen. And it's pretty exciting to see it in action.
so you didn't, or you said before that you don't really center the fact that the vehicles are electric. However, I'm thinking, I have an electric car, and so I know you got to deal with charging, and there's like range anxiety, which really isn't, for the most part, a big deal with cars, but um, these things must be considerations with your vehicles. So, how do you think about those?
Totally, yeah. Let me first start off by just acknowledging that electric rail is by no means a new concept, right? Like, we are standing on the shoulders of giants here. Back in the 1920s, a lot of long distance mainline track in the United States, including a few transcontinentals, was fully electrified with overhead wires, and there's no substitute for that. That is pretty awesome. You don't have to worry about any range anxiety. You're just plugged into the grid as you move. Most of Europe is able to move freight this way, Japan as well. Um, we are attempting to bring that there's a lot of benefits, right, of electric, right? There's the carbon benefits. You don't have to have the refueling infrastructure the same way. It's a lot just cleaner on communities, a lot safer, a lot less toxic material and pollution. um, but there's also some other benefits that come along with electric technology. And again, this is the same with battery or overhead. Is that when it comes to braking, you can conserve the energy that you would otherwise lose during braking events. And for trains, braking events are really, really large, right? Like, you have a huge train coming down a mountain. I mean, that generates a ton of power. And on a traditional locomotive, even using the dynamic braking, it just gets burned off into heat, and it doesn't actually get captured anywhere. And so, for whether you're doing overhead catenary or battery electric, you can store that energy and then use it for the next climb or use it to move on. And this also just generates a lot less wear on braking components. It's a lot less heat to remove. Um, so yeah, that all comes down to it. The big problem, though, is and the technology that we're building is attempting to solve is getting the amount of power that you need to operate a freight train onto a train is actually a really hard challenge. I mean, for a long time it was hard to even get that amount of power into a car, right? And thanks to a lot of advances in electric motors and batteries, we're able to get there. But the energy involved in moving a car is just so much lower than moving an entire freight train. There's two ways you can solve this. Again, you can put the power off board, and you can have overnight catenary, but the infrastructure costs are not the ROI isn't there for the railroads to go do that on long distance routes right now, and they're not interested in doing so. The other thing you can do is you can put batteries in, and you can put a ton of batteries into a locomotive. And there are a few other companies, both traditional and startups, that are working on doing this. The issue with this is that amount of batteries you need to put into a locomotive to pull a massive amount is so large that the charging infrastructure actually is the breaking point. Like, how do you plug in a locomotive with several megawatts worth of megawatt hours of battery capacity, and get power into that thing in a way that's going to not take a week to charge? It's like really hard to do. So, and then just the weight, and the number of tenders of batteries you have to have, it becomes like an unwieldy problem. So what we're attempting to do here is spread that problem out throughout the entire train. So rather than trying to focus all of the batteries up front inside one or two locomotives and battery tender cars, we are distributing the battery power throughout the entire train. It makes it a way more solvable problem. And then it comes with the benefits of now all the cars are self-powered and they can make their own moves, and you can unlock that platooning stuff that we were talking about before. So yeah, this is part of it. On a planning side and kind of range anxiety, one of the nice things about the rail network versus driving in your own personal car is that most train maneuvers are well planned in advance and scheduled. And this allows us to use our planning software, integrate in with the business systems and freight delivery systems that exist in the class ones. Any railroad, class 1, 2, 3, short lines, no matter what. And make sure that we can plan ahead our charging, right? So we have charging infrastructure that we can deploy either where the cars are actively housed, or where they're loading, or midpoint chargers. We can design a service where the charge is just another element, just like refueling a locomotive right now. We can do fast charging just like most cars can today, where you can shoot a lot of current into it, maybe even while it's loading, so you don't have a whole lot of downtime. So a lot of benefits to the electric, and obviously, with the way the electric technology has been moving, it's ready for rail right now.
So this is also a bit of a tangent, but existing freight trains, they're diesel electric, right? So it's like a diesel generator driving electric motors.
Correct. That is most mainline trains in the United States are diesel electric. Yeah.
Okay. But you're not getting all that benefit of being fully electric with like the braking, like you said.
No, I mean, and most trains brake in several different ways. They have brake shoes on all the cars that are air brakes, and those just kind of burn a blade off. But for the most part, when a train is braking during like a normal move, it'll do dynamic braking, which is very similar to what we do is regenerative braking. But there's no place to put the energy. You have to so what a traditional locomotive will do is just use a large resistor bank to send that current through and convert the electricity into heat and just vent it out. It's the only place to put it, just into the air. Whereas because we have batteries on board, just like an electric car, we can capture it and then use it later. It's very nice for the operational efficiencies.
Yeah. Um, so uh, obviously these trains, as they're moving, there's always the chance that they're gonna uh, run into unexpected conditions on the track, need to stop, that kind of thing. Obviously, that's a big problem for existing trains. Usually, like it's a big problem if they don't know well in advance that they need to stop.
Yeah.
Um, but uh, in your case, also the train needs to be able to recognize that on its own and
Totally.
react to that. So, what does the solution look like for that? Is there a suite of sensors, and what's the software? Is it AI? Is it something deterministic? How does it all
Yeah,
work?
yeah. Great question. So our vehicles are equipped with a perception suite that allows us to sense the environment, and respond in ways that a human driver would respond, and typically a lot faster and more, and hopefully we get to a point where we can prove the reliability. This includes LiDARs, includes cameras and computer vision. We use a whole suite of technologies. A lot of it, again, standing on the shoulders of giants of the autonomous vehicle industry, but adapted and run through the very strict testing requirements that you need to operate on the rail network. And so this allows us, to some degree, trains aren't really fully autonomous in any case, right? They do what the dispatching network wants them to do, and if you're doing it right, you're following exactly the rules in the train movement plan that you've been given. But to cover those unexpected circumstances, we use this sensor suite to say if there's a branch that fell across the track, or a crossing gate is non-functional or down, or if we need to move through a restricted speed area for any reason. Not only do we have those autonomous sensor suites that can help the train move and make safe decisions, but we can. It also doubles as a teleoperations backup. That if the train gets into a situation where it needs assistance, it can remote home. And this is very similar to the way that the autonomous vehicle industry works today, where there's a backhaul that can get you out of sticky situations. So as we continue to refine those, we'll be able to handle more and more cases. And again, all this is being done with the intention to prove it in a very strict manner that it meets safety requirements, and we have a lot of data to make sure that we're doing the right thing in any given circumstance.
Given that each car has its own regenerative braking capabilities, is there anything about your architecture that makes it able to stop better than a big freight train?
Yeah, we can. So I mean, in any case like this, freight trains are just heavy, and the freight you're carrying is extremely heavy. And the friction of steel wheel and steel rail, in one direction helps you achieve really, really good efficiencies when you're moving forward because there's no rolling resistance or very little rolling resistance. But when it comes to stopping, steel wheel and steel rail can't provide the friction that like a rubber tire on asphalt can provide. One advance, so we still are limited by physics there, right? We can't stop the way that your car can stop ever. It's not going to happen. However, what we do have over traditional locomotives is that because every single vehicle is loaded with sensors and it can control its own braking pressure, we can closed loop control and really maximize the braking efficiency or the braking friction, sort of like anti-lock braking on a passenger vehicle, where we can sense when we're at the threshold limit of static friction between the wheel and the rail, and we can maximize the stopping distance. So whatever the maximum braking potential of the wheel rail interface is at that moment, we can utilize that, and generally that means we can stop a lot faster than a traditional train. And I mean, you've seen traditional trains; that's famous for not being able to stop very fast. Sometimes the braking pressure from a locomotive can take a very long time to pressurize up and hit the cars at the very end to get to full braking pressure. We just immediately can and actively can close the loop on that and make sure that it happens faster.
That's kind of cool. Kind of maybe a side benefit, but a nice thing for society safety wise.
It just so happens when you do this, it does unlock a lot of side benefits that are really useful for the industry, from safety and efficiency, and being a green company. And I want to also clarify there too, like we're, even though the business case doesn't rely on it being green, to us philosophically that's really important. It's one of the reasons why I got into this. I wanted to make a difference in the way that we produce carbon in the world. And the not that this is like the biggest contributor, right? But it's pretty big. I think globally, freight takes up something like 10% of the global carbon emissions. So if we can make a dent in that, then it takes a lot of little things here and there. And if everyone else is working on all the other parts, we can all together bring down the carbon footprint.
Yeah, no, I mean, that makes total sense to me. And I also think it tracks with kind of the breakthrough for electric cars, which was, okay, we want to do an electric car because we think that's better for the world, but it has to be compelling outside of that.
Yeah.
And so it makes sense that you're not, you know, you're explaining the benefits without that, but that's also a big part
Just
of it.
happen to be green as well. That's our plan.
Yeah. Okay, so railroad, there's got to be a bunch of regulatory hurdles that are coming up. How's that all going? Have you kind of run into that, and are you working through some of those steps?
Yeah.
What does it look
So
like?
we have a very good working relationship with the Federal Railroad Administration in the United States and various other countries' regulatory bodies for our international customers. This is so central to our business, right? Like as I said, we need to be able to fit right into the way that trains currently work. A lot of that means behaving like they do, conforming to the same safety standards that they do. We take this extremely seriously at the company. And so built into our system requirements and testing requirements, we have a whole suite of regulatory validation and safety level validation that we do to make sure that we can satisfy the requirements, make sure that we can satisfy the regulators, and just in general, be as safe as we possibly can when we're out on the rail. And so to that degree, we have become, we're trying to become experts as fast as possible in all of these different regulatory environments. There are a lot of common things that various countries share and various municipalities share and railroads. There are a lot of divergent things. The divergent things can be, as small as what color temperature the headlights need to be on any given rail vehicle, or the exact geometry, right? And so there might end up being small differences from locale to locale, just like with the automotive industry. But at the end of the day, trains are trains. You need to make sure that they follow the rules of the road, that they don't go faster than they're supposed to go, that they only go exactly where you tell them to go, that they're accurate in their position reporting, and that they fail safe in a way that isn't going to harm the public or interfere with other road users. So we're very committed to that. It's been a learning process, and we have a lot more to go. But one of the ways that we're making progress in that is we've started a pilot program for the in the state of Georgia, and I think I'm pretty sure this is public information at this point. We can
I
double
think
check on
I've seen it. So
that. Yes, we're going through a multi-phase test program, heavily involved with the FRA. We have a very good working relationship with them, and we're kind of stepping through, slowly introducing more and more elements of our technology. So right now we're just about to complete our second phase of that, where we were showing crossing behaviors, our vehicles moving through crossings along the route, showing that we conform to all the rules. And that our system automatically behaves the way that the railroad operating rules require them to. And same thing, the whole system is designed, the whole test program is designed to show that in all of these operations, we're always conforming to the safety parameters, we're failing safe where necessary, and we're just building trust to make sure that we can show that we are regulatory compliant underneath the regulatory regime.
So, I think that pilot is probably the biggest milestone for you guys lately. Is there any other big milestones that you would think would be worth mentioning?
Yeah, that's certainly the most public milestone. Yeah, we're working on so right now our fleet is we call them our Mark II generation vehicles, and those ones are the ones that are out in the field and performing the pilots with various customers right now. We are working on the design and manufacturing of our production level Mark III generation. And so no public milestones yet with that, but we're really excited to reveal that when we finish building the first prototype and start serial productionizing them. And this is it's sort of like a cost optimized production ready variant that incorporates a lot of the lessons learned with the previous vehicles. The train control software is all still the same as what we used before.
Mm-hmm.
So no public milestones to share yet, but we're pretty excited to keep moving forward with this Georgia pilot, and very excited to work with the FRA getting long-term railworthiness proven.
Yeah, that what you described about the variance in regulations from different jurisdictions sounds daunting.
It's daunting, but we're up to the task. Like I said, it has to be a huge portion of what you do as a company in order to be successful in this, and we intend to be compliant.
Yeah, it just comes with the territory, right? Okay, so we've gone all this time just talking about Parallel, the company, the solution. We haven't talked Rust, which is kind of the central theme of these interviews. So let's talk about it. How does
Yeah.
it fit in your stack? Where do you use it? What does it do for you?
We, from the beginning, when we started in 2020, so I think Rust was stable for about maybe 2-3 years at that point. We are a full Rust shop. Our product software is all in Rust. From the firmware running on bare metal firmware devices, through the vehicle software running on our custom Linux distribution, which I guess isn't in Rust, but it's Linux. And then you kind of go up to our web software stack running on cloud servers. That's all Rust. And even a little bit of our user interfaces. I won't say all. There's some JavaScript in there because we're not 100% web ready, but we build it all together, and we utilize the Rust test framework to be able to get a really high degree of confidence in our system when we run through all these tests. Our test software largely in Python, just because that's an easier test framework language to work with. But our product is almost 100% Rust, and we're committed to the language, and we think that's the way forward.
It seems to be the pattern that most companies, I mean, I would say newer companies doing kind of embedded stuff seem to be adopting Rust.
So, I
Um,
mean, I learned Rust when I started at this company. I not a founder, one of the original technical hires, and I was a firmware and embedded engineer. I learned it, and obviously there's a little bit of bumps at the beginning coming from C and C++, and after about a month, I was like, oh my god, I'm never coding in anything ever again. This is unbelievable. I mean, it's basically like what someone who's worked with C++ their entire life and shot themselves in the foot a million times. If you ask them to rewrite a language from the ground up to not do that, that's what Rust ends up being. And I've time after time again seen people come to our company, start working with the language, not having any Rust experience, and then they just become evangelists. They're like, "Oh my God, this is just so much better than what we were working with before. I don't need any crazy frameworks. I don't need to." The system enforces itself. We were big Clippy users here too, so there's sort of like a common style element that, even not that people aren't allowed their own style here and there, but it does enforce a unified kind of way of thinking about using the elements of the language itself, a meta style, and that helps speed the development process throughout an entire team. It's just a joy to work with, to be honest.
yeah, that seems to be the common review that you get is like teams adopt it and it's kind of hard ramping. Um, but then once they're past that certain point, it kind of the momentum that you're able to sustain uh, developing in it from there seems to be kind of higher. Like refactors become easier
Yeah.
because you change something here and the compiler just sort of tells you everywhere else that needs to
And,
needs
and
to
that
be
and that
fixed.
can that can be annoying at the first, right? When you're just trying to get something off the ground and you're like, oh my god, it's making me do all this stuff. I just want to get something running. Like there's still human tendencies to want to get something done really quick. But then you get through all the compiler nags, and then suddenly it works, and it works perfectly. And you kind of get to this sense that at least for lower level functions, when you hit the compile button and it compiles, it's probably going to work the way that you wanted it to and not have any weird errors. I mean, a little more complicated with firmware where you're doing direct memory access and register writes and everything. There's a little bit of unsafe that needs to happen there, but on application level code, the way that I kind of think about this is it just moves all of the troubleshooting and figuring out what is busted to before you hit the compile button. It's a total rethinking of the way that I programmed before, and then combine that with the error handling system that's native to Rust. It really makes you just think through what you're doing before you actually go and try and run it, and then you are rewarded with the fact that it works the way you intended to when you click the button, and that just is a game changer right there once you get used to it.
Yeah. You mentioned that you have to use unsafe in the firmware, and that I've heard a bunch of times from embedded people, but I guess I've never really dug into that. Why is that? Is that because you're of the drivers that you're interacting with, or what's the?
Well, and this is coming from, this used to be my bread and butter. I used to be an FPGA and firmware programmer. At the end of the day, right, like when you're interacting with hardware, the hardware devices, like you're working with a microcontroller, and from the manufacturer, you get a register list as part of the hardware abstraction layer, right? And you're just, or even as just part of the registering, right? You want to go, and they say if you write this register, it'll set these bits and it'll turn on this part of the machine, right? And there's no way for the Rust compiler to know that it's actually going to work the way that the manual says, right? So a lot of times when you're really minutely dealing with the hardware, you have to just trust that it's going to do the thing that you want to do, and be really careful with your error handling to bubble up errors for when things don't work the way that you expect them to. So for that, you do have to use a little bit of unsafe. But the challenge for embedded firmware development in Rust is to get above the hardware abstraction layer as soon as possible, so you can then utilize the full features of the Rust language. And so if you can minimize the amount of work that you're doing underneath the HAL, then you get the full benefits of the system on top of it.
That makes sense. Um, to this point, or I guess continuing with this conversation, I'm like so excited about Rust for embedded right now.
Yeah.
I mentioned before, like I feel like it's exploding. I'm seeing it everywhere, and obviously the benefits are huge of having this language that's a lot safer that you can use to build things that are going to be in the real world and really need to be safe. Um, do you see any like remaining blockers for further Rust adoption in that space? Is there anything that sticks out to you having worked at this intersection?
You're bringing up some good points here that like I think everyone who works in especially safety critical embedded development understands that this is the direction that things need to go. So there's an industry zeitgeist that Rust's adoption into critical safety standards is inevitable, and that we're going to get there because that's what everyone wants to happen. The big roadblock is just you need to do it enough times. Like, I mean, there's a reason. There's a reason why safety critical and functional safety standards need to exist, right? Is that you need to be very, very careful that the thing that you say the system is going to do is actually the thing that the system does, right? And so there are some companies that are working very in the background making this happen. Like Ferrocene is working on a Rust safety, like a formally proven Rust compiler. I think when we get a little bit further along, the breakthrough will just need like a killer case, right? I hate to put words in someone else's mouth here, but I believe VW did a little bit of a test of this a few years ago where they used Rust to go through a full safety certification of one of their components. Don't quote me on that. It might be a different manufacturer. I can't remember, but we're going to need to see some big player use Rust for real and forge their way through a fully a 26262 compliance process or some sort of aerospace compliance process. I can't remember the exact standard number. And then you'll see. I think that'll be like a waterfall once it's like, oh, okay, a big boy did it, and there's a proven path, right? And now the standards recognize that this is the way you can do it. You kind of see this with like if you want to use C to write functionally safe code, you have to follow a set of standards, right? You have to use. Usually, people use the MISRA C guide, right, which restricts a lot of the ways you can use the C language in order to make it work. And one of the reasons everyone's so excited about Rust is because a lot of those restrictions are just built. They're just the rules that the Rust compiler and language follows from the beginning, right? So it's like you can't do unsafe. You can't. You have to handle all of your edge cases up front. You have to. You can't. You have to comply by the borrow checker rules. You can't just let null pointers hang out, right? There's a lot of these like little things that are just style pointers in other safety languages, but are enforced by definition in the Rust standard. So I think the pieces are all there. We just need to see it happen and get some industry acceptance, and then the gates will open and we'll be able to do it.
Yeah, it's almost like it should be easier in Rust, but it's just the kind of the history and uh, I don't know. It's almost like a form of technical debt, or like you know,
You could
procedural.
call it a well earned conservatism on the safety side, right? Like
Yeah,
you want to make sure that if you're going to accept a new methodology as part of your safety standard, you got to make sure that there's some data that it's going to work. And I know that's working in such a safety critical industry. I understand that, and we'll get there though. I think everyone wants to get there.
yeah. So, well, actually, since you kind of talked about this, how does that rub up against your work? Are there things that you're doing that need to be certified or?
Yeah, yeah. So, the way there's a number of ways to do this, and I mentioned there's industries have certain standards that they use to prove functionally safe hardware and software. Like, for instance, the ISO 26262 standard in the automotive industry is a pretty common one. If you want to make like a embedded brake controller that is gonna stop when you step on the pedal, you go through the 26262 process to prove that you've identified the functionally safe requirements, that you've designed the system to the requirement level of safety analysis and hazard analysis and documentation. You're writing code the right way. You've done the numerical analysis on the failure rates of the hardware that's involved. A lot of the software-facing standards are best practices and an engineering process, right? You need to make sure that if you have a change control process, that code is being reviewed and isn't just being updated willy-nilly in the field. Um, so Rust and our system is designed around a lot of these in the beginning. So and a lot of these safety standards too are not flexible in the way that you can just do whatever you want. But if you can prove that you're following the what it needs to do, you can get a little bit of leeway in exactly the method in which you do it, right? So yeah, there's a little bit of friction in us proving that we are hitting all of the required elements of the safety plan in a new language like Rust, where it's not as accepted, right? We'd like to get to the point where Rust is accepted enough and the compilers are formally proven enough that you can just rely on the guarantees that we built it in Rust, so therefore you don't have to worry about that. It just can't happen, right? But right now we have to go through the process of actually proving it ourselves, and that does slow us down a little bit. But like I said, we can't be in this industry without proving functional safety. So we are committed to the process, and we're going to do it as long as it takes, and hopefully Rust is accepted in the meantime, and then our next generation of our vehicles will be even faster.
Yeah. I was talking, well, I did one of these interviews with Sonair. Do you know that company?
I'm not familiar, no.
So they're building an ultrasound sensor for like robots, basically.
Mm.
I mean, it could be used for multiple applications, but and they're going through the certification process with Rust, and it was just very interesting. Sounded very hard. He was
Yeah.
describing, basically they're trying to get a certified compiler, which I think is kind of the Pharisee
Yeah.
work, and then if they can get the standard library, I think that was basically what he said, is if they can get the standard library, then they can just kind of build up the rest
Yeah.
on their own. But
And
it'll,
there are a lot of companies in the space. Shout out to Pictoris for doing this on the MATLAB Simulink kind of emulation side. There's a few other that I'm probably not mentioning, but yeah, I mean, there's a lot of people invested in this, and to just making it easier to pick up the tools and run with them, and not have to do everything from the ground up because the language is designed that way. And
yeah,
we're going to get there, I think, in the next few years.
yeah, it'll just take some work.
Mhm.
Um, okay, so uh, these interviews, my goal is always to kind of shed light on companies that hire Rust engineers. And so I do want to ask, as we're kind of winding down, some questions about what it's like to work in engineering at Parallel. And so I wondered if you could tell me about a really interesting technical challenge your team had to solve recently.
Yeah, I mean, we're a hardware company, right? I mean, a lot of what we do in our core competency is in software, but there's no way that our software works without the hardware working. So we are a hands-on company. So we have not only do we have hardware here in the office and test stands and hiddle tables and even a real vehicle that we can move around in the office. We also have a test site that's not too far away. We're always up at the test site. Our engineers are getting real time on the hardware platforms to test their code once it gets through all of the required software checks and our engineering process. But we're very hardware focused. And that ends up being like a really fun environment. Like I mean, I'm still like a kid at heart. I love working with hardware. It's kind of fun to even the smallest thing, like changing the way a certain behavior works with the one of the vehicles in a platooning action or something. I mean, you can go get your change ready to test, and you go up there and you drop it in the deployment, and then you can move these 50,000-pound vehicles around and slam them together and break them apart. And we have an engineering UI that allows us to do kind of low-level moves of the vehicles, and that's really fun. So we have a lot of ways for the engineers to get really really in touch with the hardware. In terms of technical challenges, yeah, I mean, all the time. I'm trying to think of one that's particularly relevant right now. So we have cameras that stream live video off the vehicle, and this is we rely on a number of technologies in order to get that video link off of the vehicle and back to our central servers and distribute it out to the platforms that consume it. We rely mostly on commercial LTE providers, on satellite links, and anyone who's worked in this space knows that this is not a solved problem. Getting low latency, high quality stream video from a mobile platform out in the field. Very difficult to do. It's easy to get it working poorly, very difficult to get it working reliably enough to move a very large vehicle. So this is like a work that we're constantly doing. So we have a number of kind of innovative solutions to this to both utilize commercially available networks and also cover dead zones in the networks along our routes so that our vehicles can get out there and have constant connectivity the whole time. Um, Without going into details, of all the challenges we're solving, like that's a fun problem. That's like you are out there, you are trying out different technologies, different radio technologies, trying out different video streaming technologies, and live gathering metrics to make sure that we're making improvements in the way that in our latencies and in our quality. And then you get feedback from the real operators. You get people that are actually using these things day to day, and you get to deploy a change and say, okay, gathering feedback from the users. Did this actually make your job easier or not? You get that tight feedback loop that is really validating.
That's all very cool. I mean, obviously, I smiled when you were talking about using, going and testing your code and actually moving around these big vehicles. Sounds pretty fun.
Yeah, it's pretty definitely the most metal I've ever moved with a code change. That's for sure.
That's a great phrase. Um, so I guess another thing that would be good to ask is about kind of the employees and what do you think? I mean, you've probably hired a good number of people at this point and seen people come and go. What do you think are big predictors of whether or not someone's going to be successful at Parallel?
Yeah, we do hire a lot of people who are passionate about Rust. I've it's my I mean I always man I spring for if I see Rust passion on a resume, that goes right to the top of my stack because it's my personal opinion that people who love Rust tend to be really good programmers and tend to think about things in the way that is helpful to solve real world problems. So that's number one. I mean, like we hire a lot of our employees are here because they want to work with Rust in a real world problem, and those employees are definitely the most successful. Not just because they know the language and they can jump right in, but because they have the mentality of like what actually makes code reliable and what makes it work. I would say in general, what we do, and with any hard tech company, when you're interfacing with things in the real world, the mentality is a little bit different than working on things that are more in the web space, right? Like when a web app crashes, you can reload it, and there might be some, externalities or some effects of that web app crashing, but generally people don't die from TikTok not loading fast enough, right? And there's a little bit of a mentality shift when you come over to the hard tech space where like stuff has to work and there's no excuses, right? And not just work empirically, you have to know it's going to work before you go test it. And so that testing upfront mentality just jives right with the Rust philosophy, right? That you're going to do everything ahead of time and prove that it works before. Employees people that come into the Parallel that have that mindset, that have worked with hardware before, who know the what it takes to make things work in the real world, and then that can't just accept, oh, we'll just we'll restart the system and then it'll work the next time. That's pretty critical for being successful, and we have a track record of people coming in that have done really well with that.
So the other thing I wanted to ask about, you mentioned it at the very beginning of the interview, that kind of SpaceX heritage of the company. Um, the Elon family of companies have a hardcore reputation.
Yeah.
So is anybody sleeping on the floor at Parallel?
No, the way that I like to phrase this is that we strive to import the positive elements of that SpaceX culture. I love
Yeah.
SpaceX. I cheer for them at every launch. I really relish the time that I spent there. One of the things that we do carry with us is a radical ownership culture. So this is very very big at SpaceX, and one of the reasons they're so successful is that they empower individual employees to own the outcomes of their projects from very early on at your time in the company and even your career. And so we really think that that's the best way. You give an engineer full control over the thing that they're working on, and they can make decisions. Really big decisions. Obviously, you want to get you want to write it out and make sure everyone agrees that we're going to make those decisions correctly. But giving engineers a lot of autonomy in how they solve problems. It comes with the benefit, that really enables the engineer to go find the right solutions, to act quickly, to kind of be their own advocate. But then also, when it comes time for that product to work or for that feature to be demonstrated, it's their job, right? It's your responsibility to make sure it works. And I think that's exhilarating. It can be stressful at times for sure. When crunch times happen, we do have to put in a little bit of extra hours here. When we're deployed, we need to be on call. We need to make sure that our vehicles that are out in the field are actually going to be supported properly, and that we're making changes that are responsible and via all the safety requirements. And but I wouldn't say that we're I wouldn't say we're telling people that they got to sleep on the floor. I think the way that I would phrase it is, we want to make sure that people aren't burning out, but when crunch time happens, you got to pick it up a little bit and make sure that you can meet deadlines and you can support the field teams. And the nice thing too is that a lot of our engineers have spent time in the field, so they know that when we're out testing a new feature, what it's like to be on the other end of the phone when something breaks or doesn't work the way it's supposed to, and so there's a lot of respect for making sure that you put the extra effort in when it counts.
Yeah, that sounds totally fair. I just wanted to glean a sense of kind of the work life from that perspective. And I
Yeah.
think I think there's such an appetite for people to work on stuff like this, real stuff that's going to make a real difference in the real world. So even as you say, like where there's situations where at crunch time you have to show up, um, I think a lot of people want that.
Yeah, I mean, it's I wouldn't have it any other way. I'm kind of addicted to the startup way of life here. So I think there's a lot of cultural alignment that, especially with that ownership culture, right? It's like, oh man, you kind of look to your left and look to your right, and you're like, oh, I'm the person that needs to solve this problem right now. I got to step up. I got to make sure that this happens. I got to make sure that I can get this done on time and it's going to work correctly. And if it doesn't work correctly, I know quickly how to resolve it. We've got a pretty positive culture around that right now, and people are excited to make things happen in the road. I mean, who wouldn't get excited to go move trains around with their software? It
Yeah,
lends itself to that kind of excitement.
yeah, no, it's awesome. Um, okay, so we may have kind of gotten to this, but my last question was basically, how would you distill sort of the vibe of the people that work at Parallel and kind of the culture?
Yeah, great question. We are a small team. It is I sometimes describe it as like a pirate ship, where it's sort of like a motley crew of very motivated characters that all, in addition to having our individual specialties, are very used to pulling together and making magic happen. Whether it's hardware or software, pulling rabbits out of hats. Um, you putting a very small amount of resources together to do really big things, and having a lot of fun while we're doing it. We are gonna stay lean. We're gonna stay scrappy. We don't have plans to massively scale up the team anytime soon. So really, what I'm looking for in new hires to come here is a willingness to do a lot with a little, to work on things that are going to affect the planet in a positive way, to be motivated by all that, and to kind of come together with this crew of characters to make some trains move around.
I think that's a good place to stop. Thanks, Tom.
No problem. It's been a pleasure.